All right, folks, it is part 3 of note 73, and we're going to do some solving radical equations, which if you were watching the video for note 72, you saw a little bit of the very, very last question on the third video when we were solving for a 0. So to solve a radical equation, right, like problem number 3, part A here, we have a radical, it is equal to 0. We are going to undo the radical by squaring both sides, right? Everything in math has an inverse operation, and the inverse to square root is to square something. So on the left side, the square and the square root undo, leaving behind 2x minus 5, and 0 squared, right, is still 0. And let's solve it. So let's go ahead and add 5 to both sides. So 2x is equal to 5, divide both sides by 2, x is equal to 5 halves. Now, this is the part where I'm kind of pausing here because what we should now be doing is checking this solution. Because unfortunately with radical equations, it is possible to solve these problems and create extraneous solutions. So what I'm going to do is go back to the original problem, way back to the beginning where there was an x, right, before I made any changes to anything. And I am going to replace x with what it equaled. All right, so 2 times 5 halves, the 2 divided by 2 cancels, and I get 5. 5 minus 5 is 0. And yes, folks, the square root of 0 is 0. That is a true statement. And what that tells me is not that my answer is 0, it's just that I tested the answer of 5 halves, and that is a true statement. That is a good answer, okay? So I'm going to slide on over to part B, because now with part B, I have a radical, right? Here's my radical. The problem is the radical isn't by itself. We've got this random minus 2 hanging on that I want to get rid of. So before I do any kind of squaring of anything, I'm going to go ahead and add 2 to both sides. So square root x plus 3 equals 0 plus 2 is 2. Now that the radical is isolated, I'm going to go ahead and square both sides. On the left side, the square and the square root cancel as they should do. On the right side, 2 squared is 4. I'm going to go ahead and subtract 3 from both sides, and I get x is equal to 1. But of course, I say of course, but yeah, we got to check this, okay? And the check isn't supposed to be some big, huge thing other than the fact that I write huge. But you do want to make sure you're doing it to check, whoops, I don't know what that was, to check this answer in the original, all right? So I went back to the original. I had the square root. I have my square root, and then it said x. Well, I left that blank originally, then plus 3 minus 2 equals 0, and I replaced x with what we just figured out it equals. So if I do the quick check, I've got 0 plus 3. Well, that's 4. So the square root of 4, well, the square root of 4 is 2. 2 minus 2 is 0. Yeah, 0 is equal to 0. That is a true statement. So again, we've got a value that works. X is absolutely equal to 1. So far, so good. But wait, there's another one. All right, so for part C, I'm going to go ahead and start doing this one the same way I did with part B. I want to get the radical, the square root by itself. So that means I need to subtract 3 from both sides. So square root of x minus 4 equals negative 3. I'm going to go ahead and square both sides. So square and square. Those cancel. We've got x minus 4 equals negative 3 squared is 9. And then I'm going to go ahead and add, whoops, why am I adding 5? Let's add 4 to both sides. Helps if I can count. 9 plus 4 makes 13. All right. So I kind of have a feeling that my answer is supposed to be 13. But again, I got to check this. So I'm going to go off to the right side here. So I've got my square root. Where I have an x, I'm going to leave it blank for right now. So minus 4, then plus 3 equals 0. And we figured out that x was 13. So quick checks here. 13 minus 4 is 9. All right, so I've got the square root of 9 plus 3. Well, the square root of 9 is 3. And 3 plus 3 equals 0. I have a problem with this because 3 plus 3 is 6, not 0. So that is a false statement. This is absolutely not the correct answer. It is mathematically considered an extraneous solution. And so what you're going to tell me is there is no solution. Okay? And that happens sometimes with these problems. You can, again, when we're talking about a function like this, and we're trying to set it equal to 0, what we're looking for is, does this cross the x-axis? And in this case, it doesn't, right? It just doesn't cross the x-axis. So there is no solution. No value of x will make this function equal to 0. But here's the problem. You notice the work that we did in part B and the work that we did in part C are very similar in what we have to do, right? We've got this term that we've got to get rid of. We got the term we've got to get rid of. We did that. We squared both sides. We squared both sides. All right, cool. We solved for x, And in one case, we found a solution that does work. And in one case, we found a solution that doesn't work. So that happens. The easiest way in the part C to notice that you're probably going to have an issue with it is when we did this very first step here, where we got the square root was equal to a negative. All right, that is a big tip off that it is likely you are not going to have a solution there. All right, there's one more problem here that we're going to do, which is problem number 4, which says, kind of like what we did in note 72, find the domain in the zeros. All right, so domain. D, because, you know, I'm super creative that way. For domain, I want to take the square root. Actually, I just want to take the expression under the square root. So x minus 2, and I want that to be greater than or equal to 0. So I'm going to solve for x by adding 2 to both sides, which means x is greater than or equal to 2. If you want to throw out a number line, you can. I don't really care if you do or don't. What I care more about is that you write the interval appropriately. And so this is going to be any values that are greater than 2, so things like 3, 4, 5. So for our domain, we have 2 to infinity. Infinity takes the parentheses there, and 2 is going to take a bracket. So that is your domain. And of course, we also need to find, I'm going to do z for zeros. Give myself a little space here. So slide that on down. And z for zeros, or 0 singular. It doesn't matter to me. What then we're going to do is we're going to take this whole function and just set it equal to 0. So 0 is equal to square root x minus 2 minus 4. So I want to get the root by itself. So I'm going to go ahead and add 4 to both sides. So let me zoom in on this. Let's see, we've got 4 is equal to the square root of x minus 2. I, of course, right, need to square both sides. So on the left side, 4 squared is going to be 16. So square and square root cancel, x minus 2. Go ahead and add 2 to both sides. I'm going to get x is equal to 18, maybe. Okay, maybe. So the check is to go back to the original equation before we made any changes. So 0 is equal to the square root of, let's see, 18 minus 2, and then minus 4. So underneath the root, 18 minus 2 is 16. So square root of 16 is 4. 4 minus 4, I'm getting 0 is equal to 0, which is absolutely a true statement, which means that, yes, in fact, your 0 is the number 18. All right, so when x is equal to 18, you cross the x-axis, your function is equal to 0. It works out, all is fine, all is dandy. And that is the end of the video for it's the third video for note 73. So a little bit of work on finding some domain and zeros in the last one, or for problem number 3 was just solving radical equations. As always, please let me know if you have any questions or concerns, and I will see you in the next one.